There. So this is gonna be the video recording for your reviewers or reviewer for the midterm. Okay. So which of the following is an irrational number? Okay. So I'm not gonna make this one as complicated anymore. So when you say irrational number, again, we have when you say irrational numbers, right? Those are numbers that cannot be expressed in fraction. That's what we discussed in class. And also, the best example for irrational numbers, we can have pi, right? We can also have like square root of 2, square root of 10, because those numbers are not perfect square, right? So, once you saw automatically a number with pi, okay, automatically that's an irrational number. So, our answer here should be letter D already, okay? Sir, why not the square root of 81? It has a square root, right? Why not the square root of 81? Okay, so you have to take note, okay? Take note that 81 is a perfect square, right? And when you say square root of 81, it would mean you have to think of one number that when you multiply by itself is going to be 81. And there's a number, right? And that's 9. 9 times 9 is 81. So this one here, this letter C is correct. I mean, this is still rational because this one is going to be 9. And again, 9 is also a rational number. Again, the answer here is simply the negative 3 pi. Or what else are examples of irrational number? We can also have like pi, we have 2 pi. Okay, I have this one is clear with you. We have pi, we have 2 pi. What else? Square root of 5, square root of 2. So those are the examples of what we say irrational numbers. Okay, let's have the next one already. There. So the question is, what is the best classification for negative 45? Okay, so this one here, let me try to draw first our illustration regarding rational and irrational number. Okay, just please bear with my handwriting. I really do have a good handwriting. I'm just kidding. So there. So we have this one here. Okay, so um, this whole box here, all of this are what we call real numbers. Okay, real. And by the way, the opposite of real numbers is not fake numbers. Anyway, so this one here is irrational. Okay. Again, the examples of irrational numbers. What do we have? Let's say we have here square root of 2. We have pi, right? So those are the examples of irrational numbers. What about on the other side? We have here our rational numbers, right? And inside rational numbers, we have here what? What we call integers. Integers there. And then inside integers, what do we have? We have whole numbers. Okay. And inside whole numbers, we have this, what we call natural number or counting numbers. Okay. There. So this one, for the I'm not gonna put that much examples here anymore, but you can refer on your notes. Okay. So examples of counting numbers, of course, how do you count? You have the 1, 2, 3, 4, 5, like that, right? For whole numbers, you just have 0, 1, 2, 3, 4. Again, this one is in your notes. Just please double check. Also in the slides. Integers, we have examples, negative 3, negative 2, negative 1, 0, 1, 2, 3. For rational numbers, here, we already have the decimals and the fractions. Okay, so let's go directly to the question. What is the best classification for negative 45? Of course, definitely, negative 45 is what? It's a It's a real number, right? Again, considering our lesson, all the numbers you can imagine of or think of are definitely real numbers. Okay. Is negative 45 rational? Yes, again, examples of rational numbers. We have like 1 half, we have 0.25, we have negative 5, negative 4, negative 45, 1, 2, 3. So it's still rational. Is it an integer? Yes, it's an integer, right? A negative integer. Now, is it a whole number? Is negative 45 a whole number? It's not, right? Because whole numbers are only 0, 1, 2, 3, 4, 5, and so on and so forth. So negative 45 is not a whole number. So our answer should be what? It should be real, rational, and integer. Or that one match with our letter D there. So our answer here is integer, rational, and real. Okay, I hope this one is already clear. Next one. There. So the question here says, what type of number must represent the total number of people wearing glasses inside your classroom? So, okay, so let's just assume, okay? Let's say we have here 10, okay? Let's say there are 10. There are 10 numbers, sorry, 10 students that are wearing glasses. Okay, so you can just, again, we can also refer to our previous slide a while ago. Is the number 10 real number? Yes, it's a real number, right? But can we still categorize it? Okay, because there, no, I will just refer to the previous slide a while ago. Again, our number is 10, okay? So definitely 10 is a what? Real number, right? It's a real number. And then is 10 a rational number? Yes, right? An integer? Yes, also. A whole number? Yes. A counting number? Yes. However, okay, in our choices here, the now the narrowest or the possible answer we can have is only the whole number. Again, 10 is a real number, a rational number, an integer, a whole number, and a counting number. So the smallest group we can categorize the whole number is, sorry, a 10 is is a counting number, right? However, there is no option here saying counting number. And the best answer we could have is only it's only whole number. Okay? I'm sorry, I keep on making errors with my terms. It's just 4 a.m. in the morning. Anyway, so let's continue with the next one. I hope this one is clear already. Again, the best answer here is whole number because 10 can be classified as a real number. Okay, this is also a rational number, but again, that's not yet the final answer because furthermore, we can still classify that one as what? An integer, also a whole number, and a counting number. Again, there is no counting number in the choices, so the best answer we could have is only whole number. Okay, there. Next question. So, what is the GCMF? Okay, the greatest common monomial factor of the expression. We have 4 40x raised to 4 minus 22x cubed plus 24x squared. Okay, so let's do this one quickly. So we have here the numbers 40, negative 22 or 22, and then 24. So what was the largest number you can think of that can exactly divide all of them? You think of 4. Are all of them divisible by 4? No, right? 22 here is not divisible by 4. So the GCMF or the GCF of those numbers is only 2. Again, it's only 2. All of those numbers are divisible by 2, but not by 4. Now, regarding the x, okay, is x common? Yes, it's common with all of them, right? But which power, sir, do we use? Which power do we use? Again, we will just use the lowest power. And the lowest power is 2. 4, 3, 2. What's the lowest? 2. So our answer here is simply letter D. Okay, next one. Here. So, which of the following expressions is equivalent, when you say equivalent, equal, right? Or the same to b squared minus 80b plus 1600. So again, the analysis here is what? This number in the middle here, the negative 80, is what? This is our sum. And then the 1600 is the what? It's the it's the product. So the what you should think of right now is like, what are those two numbers that when you multiply is gonna be positive 1600, okay? And then when you add, it's gonna be negative 80. There. So definitely, um, you will think right away of, let's say, 40 times 40, right? Because that's gonna be 1600. Or some, they might find it hard because the numbers are quite big, okay? So what else can we do here? We can actually go check the choices, okay? Because since there are choices here already, so let's try to use it, okay? So we have here the first option is this one, okay? So v plus 80 and then the v plus 20. So what are the numbers? We have 80 and 20, okay? Both are positive. So let's check. What is the product of 80 and 20? What is 80 times 20? The answer is what? The answer is 1600. So the product is correct, right? Again, it's 1600. But if we will check our sum, what's 80 plus 20? The answer is 100. Is it the same with our sum here? The sum should be negative 80, right? Not 100. That's why letter A is already wrong. Okay, now let's go check letter B. Okay, letter B, we have here 40, positive 40, and then positive 40. Okay, so what is gonna be 40 times 40? That is 1600. Okay, and then what's their sum? So again, the product here is correct, 1600. But let's check the sum. What is 40 plus 40? That is 80, right? But we're looking for a sum of negative 80. That is wrong, right? So letter B is wrong. Let's go. Let's check. Let's check letter C. We have here b minus 80 and b minus 20. So we have negative 80 times negative 20. Let's check first the product. So negative 80 times negative 20, it should be positive 1600. Okay, there are two negative signs. Next, let's check the sum. Negative 80 plus negative 20. What's the sum? Negative 100. Is it correct? Definitely no, right? Because we're looking for a sum of, again, negative 80. So this letter C is also wrong. Okay, let's go check letter D. We have here negative 40 and then negative 40. What is negative 40 times negative 40? Answer, 1600. It's positive, right? Because there are two negative signs. What about negative 40 plus negative 40? The answer is negative 80. So is this correct? Definitely yes. Our product is 1600 there, and our sum is negative 80 there. So our answer should be letter D. Okay, I hope we're good with this one. Again, at this approach, I just use this one uh, to maximize that our choices. Okay, so let's have the next one there. So evaluate. So this one is power rule, right? Power of a power rule. So we have here 3x raised to 5 and then raised to 20. Okay. What does it mean again? So what do we do here? Simply, okay, let's take note that both the 3 and then the x raised to 5, okay, both the 3 and the x raised to 5 are inside the parenthesis, okay, with the power of 4. So both of them should also have the power of 4. Okay. Now, what is 3 raised to 81? What does 3 raised to 81 means again? 3, sorry, 3 raised to 81. I said 3 raised to 4. I just said the answer. Sorry. 3 raised to 81 is so big. Anyway, so 3 raised to 4, it means 3 times 3 times 3 times 3. So you have to write the number 3 4 times and then you have to multiply it. And that's actually 81. Okay, so we have here 81. So what about this one here? We have x raised to 5 and then raised to 4. Again, that's power of a power rule, right? So what will happen there? What will happen? It's gonna be simply we just copy the base, the x, and then we multiply 5 and 4. What's 5 times 4? That's 20, right? So this is our answer already. Okay. So this one, it has no choices because I don't know, it's hard to make choices here. I mean, it will take time to make choices. Anyway, but don't worry, this kind of questions in your exam has choices. Okay. So let's continue. There. Excuse me. Okay. So evaluate. So when you say evaluate, it's like you just have to simplify or solve. So 36x raised to 7, y raised to 8, all over 9x raised to 4, y raised to 3. So this one here, let's start first with our numbers, okay? Our coefficients. We have 36 and then 9, okay? What is 36, okay, divided by 9? What's that? It's gonna be 4. And the result of the division, we put it there in our numerator. Okay, 4. Now, let's go to our first variable, x. So in this case here, I want you to focus only on the variable x. Okay, so we have here this one, x raised to 7 over x raised to 4. What's this rule? This is your quotient rule. And what do you do in quotient rule? You subtract the exponents. So the answer is x raised to 3. So for x, again, the result of your quotient rule, you put it here in your numerator. Okay? Next, we have the y. I want you now to focus on y. You have y raised to 8 over y raised to 3. Again, we just do subtract our exponents. The answer is y raised to 5. So, there. So what about now? There's no denominator. Well, if there's no denominator, you remove your bar there. So the answer or the final answer should just be 4x cubed y raised to 5. Okay, I hope this one is clear already. Next one, there. So convert the 7 over 12 into decimals. So again, this is conversion of fractions to decimals. And again, you know, there might be some other ways here. Like some we already might see patterns, okay, or other techniques. But let's just do this one using the general approach, wherein you have to take note that 7 over 12 is actually the same with what? 7 divided by 12, like this. Okay? So, what should be our answer now? So, we just have to do our long division. We have here 7 divided by 12. Okay. So, we have to take note also that after the 7, there's a decimal point here. Okay? And after that decimal point, there are unlimited number of zeros. Okay? Unlimited number of zeros there. So let's start first dividing 7 by 12. What is 7? divided by 12. Should we have 1? So I put here 1. What's 1 times 12? It's 12. And if we will do 1 minus 7, sorry, if we will do 7 minus 12, it's going to be negative 5, right? Negative 5. Is that allowed in division? That's not allowed. So that's why actually we will start here with 0. What is 0 um, what is 0 times 12? It's going to be 0. And if we will subtract 7 minus 0, it's going to be 7. There. And then we bring down our first 0 here. So we have now here 70. Okay. So what is 70? By the way, I forget something. So our rule here is the very first moment we bring down a number after the decimal point, we have to put here our decimal point. And again, they should be aligned, right? There, they should be aligned. Now, what is 70 divided by 12? That should be what? Can that be 6? No, right? Because 6 times 12 is 72. It's over than 70. So we'll have here 5. And 5 times 12, again, 5 times 12 is what? 60. We do subtraction. 70 minus 60, that will give us 10. We bring down our next 0. Now we have 100. What is 100 divided by 12? Okay, I should put here 8. What is 8 times 2? That is 16. Carry 1 here, right? What is 8 times 1? That's going to be 8 plus 1 is 9. So 96. So 100 minus 10, 96 should be 4. Bring down another 0. We have here 40. Divided by 12, we should have here 3. Because 3 multiplied with 12 is going to be 36. Do subtraction. We have now another 4. We bring down another 0 here. We'll have 40 again, right? And again, 40 divided by 12 is 3. So what will happen here? So 3 times 12 is another 36. It's going to be another 4. We do subtraction. 40. So the number 3 is going to be keep on repeating. Okay? The number 3 should be repeating. So what should be the answer? 0.58. The number 3 that is repeating, you have to put a bar on top. This one here is our final answer. Okay? 0.583 with a bar on top. Again, I didn't anymore continue this one here because the 40 is going to be repeating, or the number 3 will be repeating. Okay? I hope this one is clear already. Next one. So solve for x in the equation x cubed is equal to negative 729. So simply, so since you have here the choices already, let's not make it complicated. What you do is you check all of them one by one. You raise all of them to the power of 3 because you need to look for the value of x. When you say solve for x, you have to know what number is that. What number is it that when you raise to 3, okay, will become negative 729. So take note, it's negative 729, huh? So let's say we have here the negative 9, and then you give it. What does it mean? Negative 9 times negative 9, this is for letter A, huh? Times negative 9. How many negative sign do we have here? 1, 2, 3. There are 3 negative sign. And if there are 3 negative sign, again, what should be the answer? It's going to be negative. And what is 9 times 9 times 9? It is 729. Well, we're just checking the first option. We have the answer already. So the correct answer here should be letter A. Because negative 9 raised to 3, okay, is going to be negative 729. So that's it. We'll not check anymore the others because that's already the answer. Again, when you say x cubed raised to 729, sorry, x cubed is equal to negative 729, and then you need to solve for x. It means you need to check one by one the choices, okay? And then you cube or you raise all of them by 3, raised to 3, raised to 3. And then check which one will result to negative 729? And the only answer is letter A. Okay, next one. There. So which of the following is the best estimate for the square root of 45? Okay, so let's start first with the typical solution here. So what you do here is you try to think of two numbers, okay, two perfect square numbers. In between what two perfect square numbers can we find 45? So what are the perfect square numbers again? Okay, so what's 1 times 1? 1. 2 times 2, 4. 3 times 3, 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. Then I stop. Why did I stop? Because we're only looking for 45, right? So 45 is here in between 36 and 49. So if we will look for the square root of 45, it's just actually in between the square root of 6 and the square root of 49. What's the square root of 36? It's going to be 6. The square root of 49, it's going to be 7. So that's why the answer is here, or the possible answer should be between 6.6 and 7. Okay, and since we'll just consider only one decimal place, the possible answers are what? 6.1, 6.2, 6.3, 6.4, up until 6.9. Okay, and actually that can be reflected right away in our choices. We have here 6.3, 6.5, 6.7, and then 6.8. So what do we do? So to avoid any uh, more work, we can, since we have choices here, let's check them. Okay, so these are all the possible choices, right? Because 6.3, 6.5, 6.7, and 6.8, all of them are in between 6 and 7. Okay, so what do we do is we just check their squares. Okay, what is 6.3 square, 6.5 square, 6.7 square, and then 6.8 square. Okay, so whichever will result the closest to 45, that's your answer. Okay, but let's try to limit the work because squaring these four numbers is gonna be kind of long, right? So where can we find 45? Is 45 much closer to 36 or to 49? Definitely to 49, right? 45 is much closer to 49. So to illustrate that one, let's say we have here 36, this is 49, and this, and 45 will be somewhere around here, right? So this are like 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. Okay? So definitely 45 is much closer to 49. So what I'm saying here, since 45 is much closer to 49, the possible answer should also be much closer to the square root of 49, which is 7. So our answer must be closer to 7. So which one are the closer to 7? We have the 6.7 and the 6.8, right? Not the 6.3 and the zero point 0.5. So let's just check those two, okay? Let's say you try first the 6.8, okay? What is 6.8 squared? Okay, the 6.8 squared, it means you have to multiply 6.8 by itself. Okay, so I'm doing this one here for those who are still confused with the multiplication. What is 8 times 8? That is 64. Okay, carry 6 here. What is 8 times 6? 8 times 6 is what? It's going to be 48 plus 6 is going to be what? 54. Okay, and then what is 6 times 8 again? That should be 48. Carry 4. What is 6 times 6? That's going to be 36 plus 4 is 40. So we have here 42, carry 1, 6, 4. There. 46.24. But we're looking for what? 45, the closest to 45. So 6.8 squared is equal to 46.24. But I guess that's not yet close enough, right? That's quite big. So let's try the smaller one, the 6.7. What is 6.7 times 6.7? 7 here. 7 times 7 is what? 49. Carry 4. Okay. What is 7 times 6? This is 42. Plus 4 is 46. Okay. Next. What is 6 times 7? That is 42. Carry 4 here. What is 6 times 6? That is 36. Plus 4 is 40. There. So we have here 9, we have here 8, we have here 44. So 6.7 squared is equal to 44.89. Which one is much closer now to 45? Is it the 44.89 or the 46.24? Definitely, the 44.89 is much closer to 45, right? So that's why the answer should be 6.7 or the letter B. Okay, I have this scale ready. If it's not yet, you can just try to um, go back to the video. Okay, so let's continue to our next question. There. So which of the following symbol will make the statement true? So we have your less than, equal, greater than, and then the approximately. Okay, approximate symbol. There. So we have here. So it's 16 plus square root of 10 and then 16 plus 10. So this one actually, we don't have to do everything, okay? Because as you can see here, if we will start first with square root of 16, what's the square root of 16? That's definitely 4, right? We have here 4 plus 10. What's 4 plus 10? 4 plus 10 will give us, what? 14, right? And then we're going to compare that on the left side. 16 plus square root of 10. Well, I guess you can see already where this is going, right? So the left side is 16 plus square root of 10. So 16, and then you will still add now a number, right? And then the right side is only 14. 16 by itself is automatically greater than 14 already. So the answer should be what? It should be greater than. Again, 16 alone is already greater than the 14. Okay? That's why I will not anymore estimate the square root of 10. The answer here should be letter C. Okay? Let's continue to the next one. There. Which of the following symbols will make the statement true? So this one, let's try to estimate. But let's try to lessen the estimation or not that really much exact. Okay? So square root of 2. Start first with square root of 2. Recall again our perfect square numbers. We have 1, 4, 9, 16, and so on and so forth, right? So where can we find the square root of 2? Or where can we find 2 here? 2 is in between 1 and 4, right? And what's the square root of 1? It's 1. Square root of 4? 2. So the square root of 2 is just in between 1 and 2. So for efficiency here, let's just use what's the number in exactly in between 1 and 2. It's what? Let's just use that one first. It's 1.5. Well, you can still you can still use our method last time. Like we will really know what's the best estimate, but this time we will just use a uh less accurate estimation. Okay, I just use the number in between 1 and 2. This one is for easier or faster computation. Now, what about square root of 8? 8 is in between 4 and 9. And again, the square root of 4 is 2. And the square root of 9, okay, is 3. That means to say that the square root of 8 is in between 2 and 3. Okay? And in between 2 and 3, like the exact number in between 2 and 3 is 2.5. So in our estimation, I will just use first 2.5 as the value of square root of 8. Okay? There. So we have here, it will become now 12 minus the square root of 8 will become 2.5 and then blank. 8 minus the square root of 2 will become 1.5. There. What is 12 minus 2.5? I hope you can still recall your decimal. So that's gonna be what? That's gonna be 9.5 blank. What is 8 minus 1.5? That's gonna be 6.5. And definitely 9.5 is greater than 6.5. The answer is letter C. Okay, next one. 15. No, it's slide 15, but not number 15. Okay, so this one is already our factoring. So factor completely. X squared plus 14x plus 33. What does it mean? It means, again, this is our sum. This is our product. Okay, so you try to think of two numbers that when you multiply by itself, it will become positive 33. And then when you add, it's going to be 14. Okay, I'll pause first for a while. You try to think of two numbers that when you multiply is 33 and then when you add is 14. So the answer should be what? You can pause first the video if you want to, but the answer should be positive 3 and positive 11. Well, I guess these are the only factors, right? Aside from 1 and 33, because 3 times 11 is 33. But if we will check also the sum, 3 plus 11 is gonna be 14. Again, let me write first at 1. So here, again, 3 times 11 is 33. And 3 plus 11, I wrote the answer already. 11 is equal to 14. Again, this is the product, the 33. This is the sum, the 14. Okay, so what's the variable? It's x. X. This is our answer already. Okay, as simple as that. I hope we're good. Okay, let's continue. There. Number. Oh, this is that's the number. So we have here x squared minus 4x minus 21. So again, our analysis here. This one here is our sum. This one here is our product. So you try to think of two numbers that when you multiply is going to be negative 21. And then when you add, it's going to be negative 4. Okay? So you try to think first of those two numbers. Okay. So you can pause the video if you want to, if you're still thinking of those two numbers, but I will answer already. So those two numbers should be what? Negative 7 and then positive 3. How come, sir? Because again, negative 7 times positive 3 is equal to negative 21. And negative 7 plus 3 is equal to negative 4. The product again is negative 21, correct? And the sum is negative 4, correct? What's the variable here? X. So this one here is already our answer. And I hope this one is clear with you. Okay, so next one. So factor the expression. So this one already, the a here is not anymore equal to 1. Okay, so it's now 2. So factor the expression 2n squared plus 5n plus 2. Okay, so again, if you see this kind of example, what do you first do? Our goal here, okay, let me write first the given. So you have here 2n squared plus 5n plus 2. Your first goal here is you wanted to remove this number here, okay? You wanted to remove the number 2. So what do? You will apply. Okay, again, this one, we will use the AC method. So you will first what? You will multiply the 2 by 2. It will become now n squared plus 5n plus 2. What will happen to that 2 on the first term? It will become 2 times 2 there. I hope you're able to follow. This is the 2 a while ago on the first term. So we have now n squared plus 5n plus 4. Now, as you can see here, the a or the first number here is already equal to 1. That's why we can now apply our analysis a while ago using the sum and the product. So this is our sum. This is our product. So you try to think of two numbers that when you multiply, okay, it's going to be positive 4. And when you add is what? Positive 5. Okay, you can pause first for a while the video to think of those two numbers. Again, two numbers that when you multiply is positive 4 and when you add is positive 5. Okay? So those numbers are, again, you may pause the video first, but the answers are what? We have positive 1 and positive 4. How come? Because again, 1 times 4 is definitely 4. That's our product, right? It's our product. And then 1 plus 4 is equal to 5, positive 5. That's our sum. Okay? So it's 1 and 4. Now, what is our variable here? What's the variable? It's n. There, okay. Okay, although this one is not yet done. How come? Because a while ago, we multiplied something, right? And this time, we wanted to take it back. So, how do we take back something we multiply? What's the opposite of multiplication? Division. So this time, we will divide. Okay, but only those numbers. So we'll divide by what? We will divide by the same number we multiply a while ago. And that is number 2. Okay, this time we will divide by 2. On the right side first, we have n plus 4 divided by 2. So n plus, what's 4 over 2 here? It's gonna be definitely 2, right? However, this one, n plus 1 half, can you divide 1 by 2? No, right? That's why what you need to do is simply, you just put this number 2 here before the n. It will become now 2n plus 1. That is already our final answer. Okay, I hope you're able to follow this one. There. So it's our answer already. Let's proceed. Okay, so factor the expression 5x squared minus 18x plus 9. So again, the given here, the a here is not anymore equal to, the a here is not anymore equal to 1, right? The a here is gonna be 5 already. Okay, so let's solve. So the given again here is 5x squared minus 18x plus 9. Did I write it wrong? Okay, for a while. Minus 18x plus 9. There you go. So again, analysis. What do we do first? Okay, we need to remove first the 5 on the first term. We will what? Multiply. So it will become now x squared minus 18x plus 9 times 5, right? Times 5 here. Now what do you have? X squared minus 18x. What's 9 times 5? That's gonna be 45. There you go. I hope this one is clear so far. Let's continue. So as you can see here, the leading coefficient or the number here before our x squared is already equal to 1. So we can now apply our analysis of the sum, and here is our product. Okay, so analyze. Think of it. Two numbers that when you multiply is positive 45. Okay, and when you add is negative 18. Okay, you can pause first the video while you're thinking of those numbers. Okay, again, two numbers that when you multiply is positive 45 and when you add is negative 18. So here, what's the given here, as you can see, there's a negative number, right? So automatically, in your answers, you will also involve negative numbers. Okay, there. So I will give you the answer. You may pause first the video if you want to, but the answer here should be what? Negative 15 and negative 3. Why? Okay, let's check. Negative 15 times negative 3. Oh, negative times negative. So there are two negative signs. It's going to be positive, right? And 15 times 3 is 45. So it's going to be positive 45. So it's correct. The product is positive 45 here. Next, sum. What is negative 15 plus negative 3? So negative plus negative here, it's going to be, so it's like, again, you think of like it's your depth, right? Depth of 15 and depth of 3, negative 18. So is the sum correct? Yes. Again, product of 45 and then sum of negative 18. So it's correct. So what's the variable here? It's x. There. However, this one here is not yet done, right? Because a while ago, we multiplied something, and this time, we wanted to take it back. And how do you take it back? You do the reverse or the opposite operation. So a while ago, you multiply, this time you divide. By what number? By the same number you multiplied a while ago, and that is 5. Okay, let's start here. So it's gonna be x minus, what's 15 over 5? It should be 3 times this one. Can you divide 3 by 5? It's like, can you get a whole number when you divide 3 by 5? No, right? So what do we do? Simply we put this number 5 here before the x. So it's gonna be now 5x minus 3. So this one here is already our final answer. And I hope you're able to follow. Okay, next one. Factor the expression completely. So we have here 12bx squared plus 8b squared x minus 10bx. Okay, so this one here, what do we do is we can apply first our what um kind of factoring. We have our what GCMF, right? Because there's like quite there are like many variables here, right? We have b and x. So let's start first with the numbers. Okay, we have the 12, the 8, and the 10. What is their GCF? Or again, when you say GCF, the largest possible number that can exactly divide 12, 8, and 10. And definitely, that should be 2, right? All of them are divisible by 2. Why not 4? 12 and 8 are divisible by 4, right? But not 10. So the largest we can have is only 2. Okay? Now, let's go with our variables. Let's start with b. Is b a common variable for all of them? Yes, right? B is common. Now, what power of b do we use? Simply, let's check the lowest power of b. What's the power of b in the first term? It's 1. Here, it's 2. Here is also 1. Okay? Those are the powers of b. What's the lowest power? 1. So simply, b raised to 1. But is there a need for us to write b raised to 1? No, no need, right? Simply b. Now, let's go with x. Is x common with all of the three terms? Yes, x is also common. And What's the lowest power of x? What are the powers of x? We have here x. So we have here 2. We have 1 and 1. So the lowest power of x here is also 1. And again, no need to write the 1. So simply x. So our GCMF is already 2bx. I hope you're able to follow that one. Now we will do our division. What is 12 divided by 2? This one first. 12 divided by 2. It will give us 6. Okay. Next. B over B. So they just have the same power, right? Of 1. So cancelled. Next. We have your x squared over x. So quotient rule, right? It's gonna be what? X raised to 2 over x raised to 1. Simply, what's 2 minus 1? It's 1, right? So the answer is x raised to 1. But I guess, again, no need to write the 1. So the answer should be, for x squared over x, the answer is what? Simply x. Okay? Plus, what is 8 divided by 2? That will give us 4. What is b squared over b? Again, we just subtract their exponents, right? It's gonna be b raised to 2 over b raised to 1, right? Again, what's 2 minus 1? It's 1. But again, no need to write the 1. So simply, it's gonna be b. Now, we have your x over x. Simply cancel. Okay? Next, minus. What's 10 divided by 2? It's 5. Okay? What is b over b? Cancelled. X over x? Cancelled. Because they just have the same power. So just simply cancel. So this one here is already our final answer. Okay? I hope this one is clear already. Next one. Okay, so this one is just another factoring again. And, sir, how come we cannot use here the GCMF, by the way? Well, for this one, can you apply GCMF with the numbers 5, 19, and 12? Do they have common factor? No, right? What about n? Well, is n common to all of them? No, right? So we cannot anymore apply here GCMF. That's why we will apply our technique a while ago, or the method that is called AC method, right? So again, where do we start here? We have here 5n squared plus 19n, and then plus 12. Okay? So the analysis here is what? So what do we do first? We have to multiply the 5 to 12. Okay? So we have now n squared plus 19n, okay, plus 12 here, and then we have to multiply by 5. Again, this one is the same with our first two examples a while ago. I mean, the previous two examples a while ago. So same procedure. So what will happen now? It will become n squared plus 19n plus 60. So as you can see here, the a, or the number before the n squared, is already 1. We can apply here our technique, sum. This is product. So the analysis is, you have to think of two numbers that when you multiply is going to be 60, product of 60, right? And then when you add, it's going to be 19. So you can think of it first, or you may first post the video. Okay? So there. So those two numbers are what? They should be positive 15 and positive 4. Okay, sir, how come? What is 15 times 4? That is 60, right? What is 15 plus 4? That is 19. What's the product again? 60. It's correct. What's the sum? 19. It's also correct. Okay. What's the variable here? The variable is n. N. There you go. Now, are we done already? Not yet, right? Because a while ago, we multiplied something. Okay. Now we want to take it back. We will divide. And what's that number? That is 5, right? So we have here 5 and 5. So what is 15 divided by 5? It's going to be 3. So this is n plus 3. Okay. And then we have here next. Can we divide 4 by 5 and then we will get a whole number? Can we do that? No, right? Because it's going to be a decimal. So what do we do? Since 4 is not divisible by 5, we move the 5 here. So it's going to be now 5n plus 4. So this one here is already our final answer. And I hope this one is clear with you. Okay, let's have our next question there. So what is the quantity 8 minus 1 squared raised to 4? And then we have here all over 1 plus 6 raised to 5. So what do we do is here. So I'll just write the given. 8 minus 1 squared and then raised to 4. Like this one, huh? This one is actually about your PEMDAS. Okay, which goes first? The one inside the parentheses, right? So let's go first, or let's simplify first the one inside the parentheses. Okay? So what is 8 minus 1? Obviously, that is 7. So I'll just copy here the squared and then the raised to 4. And then all over, again, 1 plus 6 is also 7 raised to 5. Well, if you're kind of confused, okay, this one here actually can also be written as 7 squared raised to 4. So these two are just the same. Okay. And then I'll just copy the denominator over 7 raised to 5. Now, in the numerator, we can apply our what? Power of a power rule. It will become now 7 raised to 2 times 4. Right? We multiply the exponents there. And then we have here 7 raised to 5. So, continuing our solution, 2 times 4 is what? 8. So we have now 7 raised to 8 over 7 raised to 5. What do we do now? Quotient rule. It's going to be 7 raised to 8 minus 5. The answer is 7 raised to 3. Sir, do I still need to simplify? Well, this one is says written in simplest form. Okay, we have to simplify. And also, okay, take note 7 raised to 3 is kind of small, right? I mean, we will just do what? 7 times 7 times 7. Okay, so what is 7 times 7? That's going to be what? 49. Okay, 49 times 7. Okay, so for those who are still kind of confused with multiplication, I'll do it here on top. Again, 7 times 7 is already 49. And then times 7, right? So 7 times 9 is what? 63. 3 carry 6. 7 times 6 is 4, what? 28. Plus 6 is 34. So this is equal to 343. Again, in the exam, if you're kind of confused, you can ask your teacher if you need to simplify or not. Okay? If we didn't include the instruction. Okay, there. Next one. There. So this one is one of the best example on how do we apply factoring in big numbers. Okay? Somehow this would help the factoring. Okay, so the factoring could somehow help for you in doing this kind of given. Okay, so we have here 215, I will use this one for multiplication, okay? Times 84 minus 115 times 84. Okay. As you can see here, this is also again application of factoring. Okay. So how, sir? Now, is there a common factor here, a common number? Yes. What's that? It's 84, right? It's 84. So let's just use our technique. All of them or both of the terms are divisible by 84, right? So it's gonna be what now? 84 times what? What is 215 times 84? Divided by 84. Well, you cancel this one. You have now 215 minus, cancel this one, 115, right? Oh, you apply your PEMDAS. Which one goes first? The multiplication or the parenthesis? Of course, parenthesis, right? What is 215 minus 115? 215. For those who are confused, 115 there. What's 5 minus 5? 0. Okay. 1 minus 1 is 0. And 2 minus 1 is 1. So this thing here is going to be 100. So 84 times 100. That's so easy, right? 84 and with two zeros. That is already our final answer. If you're still confused, you can try to rewind the video, okay? Or go back to the video itself. So the answer here should be 8400 or 8400. That is letter B. Okay, so I hope this is clear already. Next one. This one here is combining our loss of exponents. Okay, so we have here the quantity 5 minus 2. Oops, I'm just moving it for a while. There you go. Okay, so we have here 5 minus 2 raised to 5, and then, sorry, this is the quantity 5 minus 2 raised to 5 minus 3 raised to negative 8 plus the quantity 5 plus 2 raised to 0. Okay, so I guess we can start right away with 5 plus 2 and then the 5 minus 2, because again we will follow here our PEMDAS. Okay, PEMDAS, right? So what's 5 minus 2? That's gonna be 3, right? And then we have your raised to 5 times 3 raised to negative 8. Okay, plus, what's 5 plus 2? 7 raised to 0, right? So what's the next one to parenthesis? Exponents already, right? So let's go to our exponents. As you can see, um, we have here the 7 raised to 0. Well, again, any number except 0, right? So other words we can say is that any non-zero number raised to 0 is equal to what? Is equal to 1, right? This is plus 1 already. Now, on the left side, we have here 3 raised to 5 times 3 raised to 8, negative 8. So there is a negative exponent, right? So what do we do with the negative exponent? What do we do? We actually put it down. Or also, there's actually another way. Isn't it that this one here is product rule, right? So it will become what? It will become now 3 raised to 5 plus negative 8. Because in product rule, we're adding the exponents, right? By the way, the 3 raised to 5 and 3 raised to negative 8, we did that because they have the same base, right? So it will become now, what's 5 plus negative 8? Negative 3, and then plus 1. Okay? Although, there's a negative exponent, right? 3 raised to negative 3. Is that allowed? Definitely no. What do? We bring it down. So that's why the 3 raised to negative 3 now will become what? 1 over 3 raised to 3. And then we have here again plus 1. Again, it goes down because it has a negative exponent. Now, It has a positive exponent in the denominator. Let's just simplify. What's 3 raised to 3? It's 27, right? So 1 over 3 raised to 3 is going to be 1 over 27 plus 1. But sir, how do we add this? It's a fraction and then a whole number. Well, isn't it that this one is also the same thing with 1 and 1 over 27, right? Actually, this answer is already acceptable, okay? The 1 and 1 over 27. I don't know if it's reflecting already on the screen for a while. Oh, there. I haven't seen it. I don't know if it's only on me, but I guess my laptop is a bit laggy. But okay, it's now there. So it's gonna be now. The answer actually can be already 1 and 1 over 27. But let's say you wanted still to convert it into improper fraction. Well, it's okay. How do you convert again to improper fraction? What's 1 times 27? It's 27. Plus 1 is gonna be what? 28. What's the denominator? 27. So that one is already our answer. Again, since there's no instruction whether to write your answer as a mixed fraction or improper fraction, we will consider either answer. Okay? So this one is good. Next. There. So this one is somewhat the same or same idea with our example a while ago. So you may pause first the video and then you may try it first. Okay? But if not, okay, let's continue. So here, let's start directly with our parentheses again. We have that what rule? We have PEMDAS, right? PEMDAS. And what's 6 minus 1? That's gonna be 5 there. And then again 6 minus 1 is 5, so it's gonna be squared and then raised to 2. Then we have 3 plus 2 is also 5 raised to 3. Okay? What will happen to 2 and 2? It will become what? 2 times 2 over 5 raised to 3. We have now, what's 2 times 2? Definitely 4 over 5 cubed. How do you answer this one? This is quotient rule, right? You copy the common base, you subtract the exponents. So the answer is 5 raised to 1. What's 5 raised to 1? Simply 5 again because we don't anymore write the 1. So that's our answer. Okay, next. Okay, so this one is so easy, right? So we have here the given 7x minus 7 times the quantity negative 3x plus 5. There. So it's only asking what are the outer terms. Again, this one here is about our FOIL method in the expansion. We will not actually focus much on that, but this one is just asking which one is the outer term. So remember, the 7x is the first term. The negative 3x is also first term. The negative 7 is the last term. And also the positive 5 is also last term. This negative 7 and the negative 3 here are your inner term. And then the negative 7 and the positive 5 are your outer term. Again, so the answer for the outer term, we have negative 7x, we have 7x and then positive 5. The answer here should be what? Simply letter D, 7x and 5. Okay? There. Anyway, it's not solving, so I hope that one is clear with you already. Next. There. So this one is problem solving. So a square on a large field has an area of 45 square meters. Okay, between which two integers is the length of the side of the square. Sir, what do you mean area of a square? How do you solve again area of a square? How do you solve area of a square? Well, a square is a four-sided figure, right? With all sides that are congruent or same sides or same measure of each side, right? And how do you solve the area of a rectangle? Let's say you have here um, 5 meters by 5 meters. To solve the area is what? Simply, you just have to multiply 5 and 5. And the area here is 25 square meter already. Okay? 25 square meter. So, the analysis here is what? It's saying that the area of a rectangular field is what? 45 square meter. And then you're trying to solve for the what? For the measurement of each side. So here, the analysis is you have to think of a number that when you square is gonna be 45. But since 45 is not a perfect square number, right? Okay, so that's why we will just find in between what two whole numbers can we find the square root of 45. Okay, and the square root of 45. Okay, so again, let's take note of our perfect square numbers. We have what? 1, 4, 9, 16, 25, 36, 49. So I stopped already because I'm just looking for two whole numbers where I can find 45. And 45 is in between 36 and 49. So what should be the answer? Is it 36 and 49? No. We get first the square root of 36 and square root of 49. What's the square root of 36? It's 6. The square root of 49? It's 7. So the answer is simply letter B, between 6 and 7 meters. Okay, so that's our answer there. I hope that is clear. Next one. So there. This one here, this next question is about your topic or discussion also in grade 7. This one is like there. So this one here is like converting a word problem into mathematical expression. So there. The difference of 8 times a number and 4 is the same as negative 7 times the square of a number. Write the equation in standard form. When you say standard form, it follows this one here. So we have again, and this is the same thing with our quadratic expressions, right? Ax squared plus bx plus c equals 0. There. So let's try to identify this one. The difference, okay. What does difference means? So this one now you have to be very careful. So again, when you say difference, it means what? In math, it means subtraction. So difference, okay, is minus of 8 times a number. So 8 times a number. So this number is still unknown. So we can actually use there a variable. And we can use our favorite variable, x. Okay, the difference of 8 times a number and 4 and 4. Yeah. So this one, the 8x minus 4, this is also the definition of or the mathematical conversion of 8 times a number and 4. So 8x minus 4 is the same as, you say the same as, equal, right? Negative 7 times the square of the number. This is actually the same number. Square of the number, x squared. So that's it. However, it says you have to follow this format here. So we still need to transpose the 7x squared or the negative 7x squared to the left side. And it will become now 7x squared. It will become positive, right? That's 8x minus 4. This one here is already our answer. But let's not forget the 0 there. So if you're still confused with this one, you can try to rewind the video or Simply, you can also ask me again. Okay? So, I hope this one is clear. Next question. There. So, Arshak was able to collect 5 raised to 9 gold bars in a gold quest round in a blue kit in blue kit. So, Daniel got 5 times more than Arshak. How many gold bars were collected by Daniel? Okay? So, what does it mean? So, Arshak got what? 5 raised to 9 gold bars. And then the problem says Daniel got 5 times more. So, how many gold bars were collected by Daniel? So, simply, how many were collected by Arshak? 5 raised to 9, right? And then the one of Daniel is 5 times more. So, times 5, right? What's the power of 5 here? 1, right? So, what's this rule? This is what? This is product rule. What do you do in product rule? You add the exponents. So, the answer here is simply 5 raised to 10. Sir, do we need to simplify this one? Well, if you want to, you may. But this one, uh, no need to simplify this one. This is too big, right? It means you have to write number 5 10 times and then you multiply it, right? So 5 times 5 times 5 times 5 and so on and so forth. That's gonna be too long and too big number, right? So this one here is already our final answer. Okay? So regarding the problem solvings, I know we can do all of them already. What else? Although there is another question here, there, but that one I will just leave it to you, okay, for you to search and think of. So differentiate a multiple of a number and a factor of a number. So you have to explain that one, but I will just leave it to you first, okay? So this one is this video is quite long, so I hope you will find time break to study this one, okay? So I hope this one will be able to help you pass or even get a perfect score in your midterm exam. Okay? Thank you so much.